Hi, and welcome to the video on conversion between mass and moles. This is part one of two. In part one, we're going to look at a couple of examples together, and then you're going to do two examples where you convert between moles and mass and moles using the molar mass. So let's get started with what molar mass is, since we're going to use it throughout these problems. The molar mass, which goes by many names, is essentially the mass for 1 mole of a substance. So in the case of sodium, if you look on the periodic table, that's where you can find it. 1 mole of sodium will weigh 22.99 grams. Now the molar mass has units of grams per mole. So we would say that the molar mass of sodium is 22.99 grams per mole. But we can also write that as an equation because 1 mole of sodium weighs 22.99 grams. We can write it as 1 mole of sodium is equal to 22.99 grams. And this equation is helpful because later on when we do these sort of problems, we're going to be using this equation to write our conversion factor. Okay, the other thing I want to point out before we get started is our setup. So in all of these problems, we have the same setup. We take our start, which we write as a fraction by putting it over 1, multiply it by our conversion factor, and that will give us what we're looking for in the end. And when I say start is the value that we're given, and when I say end, it's the value that we're trying to find. All right, so let's take a look at an example to sort of see how all this works out. In this first example, it asks, how many moles of gold are there in a gold bar weighing 5.0 grams? After reading these problems, we need to find what we're starting with and what we're ending with. So in this case, we're starting with 5 grams, and we're ending with, or trying to find moles. So we're converting essentially here from 5 grams to moles. Okay, now let's get to our setup. Remember, the setup looks the same. It's start multiplied by the conversion factor to get our end. So we're going to take our start value, which is 5 grams, and we're going to turn it into a fraction. Now, how do you take any number like this and turn it into a fraction, any whole number? You just put it over 1. So we're going to go ahead and do that. We take 5 grams, put it over 1. Now it's a fraction. Okay, now let's move on to our conversion factor. Remember, we're going to multiply our start by our conversion factor. So to do that, we need to go to our periodic table, because remember, we're converting between mass and moles here. So we use the molar mass in the periodic table. And what we're going to do is we're going to take whatever the average atomic weight, which is also known as the molar mass, and we're going to set that equal to 1 mole of the substance. That sort of just helps us with our conversion factor. Remember, the units that are in the periodic table, we can sort of think of those units as being just in grams when we set it equal to 1 mole. Okay, so we know that 1 mole of gold weighs 196.97 grams. Now the question is, if I'm going to take this equation and turn it into my conversion factor, what am I going to put in the top and what am I going to put in the bottom? To help us with that, we're going to focus on the units. So we're starting off with units of grams, and whatever starting unit we want, do we want to keep or cancel it? Of course, we want to cancel it. So to cancel units when you're multiplying fractions, they must be opposite to one another. So if grams are in the numerator here, that means that grams must be in the denominator for our conversion factor. Where do you see grams in this equation? Right, this 196.97 grams. So that has to go on the bottom. And then the 1 mole goes on top. All right, once we've done that, once we've set that up, then we can just sort of do the math here. So we can see that the grams cancel out, which is what we want, because they're opposite to each other. And now we go on to multiply 2 fractions. When you multiply 2 fractions, you multiply straight across. So 5 times 1 will go in the numerator, and then 1 times 196.97 goes in the denominator. And then once you've done that, you can clearly see that you're going to divide 5 by 196.97. And that will give us the value of 0.025 moles. All right, great. So before we move on to the next example, I just want to point out a couple of things. With all of these problems, we want to identify our start and end. We put our start over 1. Notice it's just over 1, not 1 mole. Very common mistake. People see 1, they think they should put over 1 mole. But no, just put it over 1 to make it into a fraction. Then we're going to multiply it by the conversion factor, which comes from the molar mass, which you get from the periodic table. And we set up our conversion factor by getting our units to cancel out. The last thing I want to point out about the conversion factor, in these conversion factors, you're always going to have 1 mole somewhere. It may be in the top, it may be in on the bottom of the fraction, but there will always be 1 mole in this conversion factor, not in the start, just in the conversion factor. All right, let's look at our second example. How much does 2.38 moles of dry ice, CO2, weigh? So let's identify our start and our end. In this problem, we're converting from 2.38 moles to grams. All right, what's next? The next thing we want to do is we want to take our start and put it over 1 to make it into a fraction. So we're starting with 2.38 moles. I've put it over 1 to make it into a fraction. Now I want to multiply by my conversion factor. And since I'm converting between moles and grams, my conversion factor here is going to come from the molar mass. So I need to calculate the molar mass in this case because we're dealing with CO2, which is a molecule. So what I'm going to do is I'm going to find carbon and oxygen in the periodic table. Since CO2 has 1 carbon, I'm going to take the 12.01, and it has 2 oxygens. I'm going to add that to 2 times the atomic weight of oxygen. And that gives me a molar mass of 44.01 grams per mole. That means that 1 mole of CO2 weighs 44.01 grams. And it's this equation I'm going to turn into my conversion factor. Now let's see if you can do it. Let's see if you can set up the conversion factor. So I want you to pause the video now, and using this equation, I want you to think about where you're going to put the 1 mole. Is it going to be the top or bottom? And where are you going to put the 44.01 gram top or bottom? And why? Great, so the 1 mole should be at the bottom of the fraction here because we want to cancel out moles. Remember, whatever unit you're starting off with, you want to cancel it out. In this case, it's moles, so we want the 1 mole to be on the bottom. And then the 44.01 grams will be on the top. And so we can clearly see that those moles are going to cancel out, leaving us with grams, which is what we want. Okay, now that we have our conversion factor all set up, we can just multiply these 2 fractions together, our start and conversion factor fractions. And remember, when multiplying fractions, we multiply numerator to numerator. So 2.38 times 44.01 goes in the numerator. And the denominator is going to be 1 times 1, which is just 1. And so once we've done all that math out, we should get 105 grams. Okay, so before we go any further, before you do the 2 examples on your own, let's just sort of recap and summarize some of the things that we covered. So first thing, after reading the problem, we identify our start and end. Second thing that we do is we write the start as a fraction by writing it over 1. Now we go into writing our conversion factor. So to write our conversion factor, we need to know whatever the molar mass of the substance we're looking at, and we use the 1 mole is equal to whatever that molar mass is. Then when setting up the conversion factor, we try and get the start units to cancel by being opposite. So in this example, we start off with moles, so that the 1 mole in our molar mass equation over here went in the denominator so that the moles could be opposite. And the end units will usually be on top because those are the ones we want to keep. Once we've done that, we're just going to multiply to solve. Okay, so what we're going to do now is you guys are going to try it with these next two examples, 3 and 4, and here's a summary of the steps listed here. So pause the video now, and when you press play again, the example and work for examples 3 and 4 will be shown. Okay, so this is example 3. Here's your start and end. We write a start over 1.85 moles. The molar mass of formaldehyde is 30.02 grams per mole, so that means 1 mole of formaldehyde is equal to 30.02 grams. We use that to write a conversion factor since we're starting off with moles. The 1 mole goes in the bottom of the conversion factor. Then we multiply the two fractions to get our final answer, 26 grams. All right, let's check our work for example 4. And by the way, before you go on to check example 4, if there's any mistakes here, you want to correct those mistakes in your work. Okay, in this example, how many moles of copper are in a 0.39 gram copper wire? So we identify our start and end. We're going from 0.39 grams to moles. We write our start over 1 to make it into a fraction. Then for our conversion factor, we use the molar mass of copper. 1 mole of copper is equal to 63.55 grams. Since I'm starting off with grams, that means that grams in my conversion factor must be in the denominator, so the grams can cancel out. And we multiply the two fractions, and we get our final answer. All right, that's it for part 1. So we're going to part 2. We're going to go through some CFUs to sort of help clarify and identify any common errors.